So welcome to our next installment of how all O-rings are not created equal. Today we're going to talk about elongation, and to start us off we're going to use the trusty Parker handbook to give their definition and go from there. So Parker defines elongation as it pertains to O-rings as an increase in the length expressed numerically as a percent of initial length. It is generally reported as ultimate elongation. And further, like tensile strength, elongation is used throughout the industry as a quality assurance measure on production batches of elastomer materials. Okay, what's all that really saying? Elongation comes down to how far can my O-ring stretch? What we need to know when looking at how far an O-ring stretch is how far do you need it to stretch, and what are the other variables that go into selecting O-ring materials and the like. Today we want to have an understanding of how materials and the material hardnesses, material curing processes impact and affect elongation. So in a nutshell, what we're saying is when it comes to elongation, how far will it stretch? And the primary reason that's important is especially the smaller the O-ring gets, there are applications where you have to be able to stretch it over a fitting, over some type of a ledge to get to the groove that you ultimately need to be able to get to. Okay? So always consider the elongation when it comes to installation. So with that, elongation gets measured by ASTM requirements in our physical properties. We talked about compression set, when we talk about tensile strength, we talk about abrasion resistance. They all fall within the ASTM D2000 requirements. So how that affects the different materials and the ratings for elongation, let's take a look at three of the most common materials that you work with in the industrial marketplace. That being nitrile or NBR, FKM or fluorocarbon, and EPDM. From a pure polymer standpoint, elongation is, as the definition, a numerical number or a percentage of the original size that the O-ring will stretch. A 70 durometer NBR O-ring, typically by ASTM D2000 requirements, will stretch 250%. In practicality, most quality compounds will exceed that significantly. In the case of a 70 durometer EPDM, you're looking at a 200% stretch. Again, most compounds, quality compounds, will exceed that by a good measure. Now, the closer you get down to 100%, the tighter that those variances will be. With an FKM or a fluorocarbon material, 75 durometer, very common, now you're looking at only 150% stretch. So from a pure base polymer standpoint, standard compounds, these are your norms. Now, how does the effect of hardness of the O-ring impact elongation? Well, let's stay with the two common NBRs and FKMs. If only thing I change is hardness and go from a 70 durometer nitrile to a 90 durometer nitrile, look what happens to my elongation. Now my elongation is only 100%. In common applications for fittings and couplings and the like, 90 durometer is a common durometer because of the properties that hardness will give. But also understand you can't stretch it near as much as you can the 70 durometer nitrile. In the case of FKM, also a significant hit from 150% for a 75 durometer to only 100% for the 90 durometer. Let's throw one more variable in there. If compression set is a significant factor in your application, a peroxide cured O-ring is a common go-to when it comes to compounds and materials. How does the curing process within the manufacturing of the O-rings impact elongation? Well, a sulfur-cured 70 durometer nitrile is really the baseline that we were comparing over here at 250%. But by going to a peroxide cure material, higher compression set material, one with a little higher tensile strength, look what happens to your elongation at the same 70 durometer hardness. Drops 250 down to 125. Base polymer, hardness, curing process all have an impact on elongation. And one last thing I want to point out, okay? There's some give and take as there is with most compounds and most elastomers when you're trying to reach a particular physical property within that. Elongation, just like any of the others, to get performance in one property sometimes means giving up performance in another physical property. You want elongation. You've got to stretch this part significantly without breaking. Okay? But in order to get that, based on the other criteria, do I have to give up compression set? Do I have to give up tensile strength? Do I give up abrasion resistance? What are the give and takes? Know the basics, elongation, how far can it stretch, but what else do I need my material to do? Again, not all O-rings are created equal.